Okay. I still see, still don't see 7 of your videos. Devon, Devon, yeah, Austin, Hannah, Jonas, Michael. I need the videos. Okay, we're gonna have a quiz at the end of the class. Okay. Share my screen. Okay. You see my board, whiteboard? Okay, good. Last time we finished the talk about the Pascal's law. Okay, do you still remember what is the Pascal's law? A very ancient, you know, physics laws, and people use it for a long time. Anybody? Pascal's. Okay, our first video project will be, let's start the first video project also. Okay, so let me give you the contents. There are 3 contents for you to choose. Okay, only 3, but you don't have much anyway. So Pascal's laws is 1 content you can test, okay, for the video project. The other content is surface tension. Okay, then the third one is the shear stress and the viscosity. Okay, so you can pick any of the content to design and do an experiment to verify the theory, one of the 3 theories. Okay, I want the quantitative measure and the validation. Okay, it's not all, you know, it's part of the grading. I will show you how I grade. You know, I have maybe 5, 6, you know, aspects. Each have 1 point associated with it. You know, if you successfully turning the project, you did a project, you probably get 4 points. The length of the video will be between 2.5 to 2.5, between 2 to 4 minutes. Okay, that's 1 point. So just make sure that's easy 1 point. Everybody should get 5 points at least. Okay, total 10 points. So 2 to 4 minutes. Okay, 1 point. You need to make sure you edit the video. Difficulty of the experiment, of the video, of the project. That's 1 point. Okay, I give you 3 subjects you to choose from. Okay, these are different difficulties. Okay, it's up to you. You know, easier experiment, you can do it well, you can explain it clearly. Okay, but difficult experiment, maybe you get more points on the difficulty. Okay, so for the difficulty is 1 point. The explanation is 1 point. Okay, you have to explain the theory and the experiment in front of the camera. It's a video project, right? So try to explain it clearly enough for elementary kids to understand. So that's my goal, you know, for the project. Explanation. What else? 7 point. Quantitative measure. You not only need to have data measured, but also need to verify. Okay, verify the theory. So for example, a lot of people confused about this is the real, I've tried to do real-time experiment for you. So you do an experiment, you try to verify something. You can qualitatively verify the theory. Say, hey, that happens. Okay, it happens, it blows, Bernoulli's or whatever. For example, you have a lot of videos on the web. So you can actually take a look what the other people did. But I want a quantitative measure in the validation. So you measure some values. Okay, for example, if you want to do surface tension, okay, yeah, obviously surface tension there. You put something on the water. First of all, you need to make sure it's not the buoyancy that floats the object. It's surface tension. Make sure. Then I want you to verify the surface tension. For example, you calculate the surface tension is 0.5 Newton. Okay, can you verify it? Actually, it is 0.5 Newton. Okay, think about this. I want a verification in the experiment. Otherwise, you're wasting your time, right? You're doing experiment is to validate and verify a theory. Okay, So that's 1 point. Quantitative measure. How well the video presentation is, also 1 point. Okay. Fun to watch, also 1 point. Make something fun in the project. So think about it. So I will post the detailed grading scale on Moodle later, but let's start working on the project. I give you 2 weeks time to do it. Okay. I don't want to give it too long. The situation is likely the midterm exam won't happen. I don't have a classroom for this class to do the midterm exam. I already talked to the secretary of the college. So we will have a final exam, in-class final exam. They will give me a room, okay? But midterm, probably not. Juho definitely is not open yet. So I need to get some fresh hold. You know, I don't know, it's uncertain. So let's not to make it the midterm exam. Instead, let's do more projects, take-home projects. How about that? Okay, I will change the grading scale, the overall grading. I will post it. I think in the syllabus we already have 2 choices, right? So I mentioned it in the beginning of the class. If midterm exam cannot make, then we have a different grading scales. I will change it a little bit. It will be more on the quiz and the projects, video projects. Okay, then basically it's a quiz, video projects, and the final exam. So that's for the semester.
Hey, Dr. Zhang.
Hey, Arthur.
If we wanted to, could we work with a teammate, or you want these individual?
That's not to work teammate. There are a lot of issues here because it's we need to make sure. I give you a project. I need to make sure the safety and need to make sure the COVID-19 stuff need to be satisfied. I cannot do it. You know.
I just wanted to check.
Yeah. I just don't want to bother to myself to get into that situation. So let's do the individual project. Okay. So, and I think it's also fair for the grading for individual projects, obviously, right? So, okay. So today is Tuesday, right? So the due date will be 2 weeks from today, okay, for the first one. Okay, so we'll talk about it later. If you have questions, feel free to ask, okay? Now, Pascal's law. What is Pascal's law? Do you remember? That's one of the project contents, right? You need to know. Anybody? I'm showing you this example on the screen. Did you still remember? The writing is not too clear, but I hope you had the notes yourself, okay? And it's about what? In the fluid, right? In the fluid, you're adding some pressure to certain point of the fluid, right? Is that right? It's the hydraulic jack here, right? This is the example we had last time. So you're adding a pressure to a certain point in the fluid. What happened to the pressure that you added? What happened to?
Everywhere gets the pressure equally.
Yeah, that pressure added to the system, to the fluid system, will be transmitted freely, 100%. Will be transmitted to the entire fluid. So everywhere will feel the same added pressure. Okay, but be careful, the sentence I just said, everywhere will feel the added pressure. Added pressure. It's not, I never say everywhere has the same pressure. That's 2 different sentences. It's 2 different meanings, right? In the fluid, of course, everywhere has different pressures because it has different elevations on different locations. Okay, but that added pressure, delta P, will be filled everywhere, no matter your initial location has high pressure or low pressure, but both everywhere will add them amount of pressure in there. Okay, that's the Pascal's law. Is that clear, everybody? That's actually to me, it's a good, easy, relatively, I shouldn't say easy, a relatively clear path to prove it quantitatively, right?
I do have a question about it.
Yeah, sure.
So if the pressure is applied, is it distributed evenly, like across the surface, or is it like?
Again, yes, it's the added pressure, added portion. It will be distributed evenly everywhere. Okay, that only the added portion, but everywhere has the initial pressure itself. Okay, of course they are changed. They are not the same everywhere, right? the added part will be filled, will be evenly distributed. Everywhere will fill that. Is that clear? Did I answer your question?
Yes, sir.
Okay. Who asked the question? Austin, right? I only show several windows.
No, that was Michael.
Oh, it's Michael. Okay. Yeah, Michael, I don't have your video yet.
Yeah, I'm working on it right now.
okay.
I might have to use my phone. I didn't know if that was okay or not.
That's okay. It's only the part when we do the quiz, you probably want to show your face. Okay.
Yes, sir.
Okay. Other than that, it should be okay. Okay, now we need to move on to new things. It's an important part. It's the pressure variation. That part actually has a lot of weights in the chapter 3. Pressure variation with elevation. Okay, first of all, let me ask you this. You did high school physics or maybe college physics, right? Do you know this? Do you remember one equation for pressure, P equal to what in physics? I think you were taught about this, right? Anybody? Do you remember that pressure equation? How do you calculate the pressure in certain point?
Rho GH.
Rho GH, that's exactly right. Okay, right? Remember this equation, rho GH. Rho G is what? In our class, I wanted you to use another letter to represent rho G. What is the letter?
Was that gamma?
Gamma, yeah, gamma H, right? Let's use this equation in our class. So that tells the story. Look at the equation. You know, you're an engineer, you're a future engineer, right? Future engineer always tell the story based on equation. Okay, a lot of you don't have that mentality yet, but that's the correct mentality as an engineer. Everything you say based on equation, then it's safe. Okay, so look at this equation. That tells you a lot of stories. P equal to gamma times H. Okay, that tells you, hey, gamma is the property. It don't change, right? It doesn't change. It's a constant property. Okay, so basically what I said, hey, in statics, in hydrostatics, pressure only change with elevation. Pressure changes with elevation, sure. This is the title of this section, pressure variation with elevation. But I like to add the word only in there. Okay, in a hydrostatics, stationary fluid, the pressure only changes with elevation. Oh, of course, it's a free system, right? If you add some pressure to it, you put whatever, pressurize it, that's a different story. But just like an open system, stationary, okay? A liquid, stationary liquid in atmosphere, okay? So basically, it's just pressure equals to gamma times H. It only changes with elevation. So the deeper it goes, the higher pressure it is, right? Is that right? Does that make sense? Is that common sense, understandable? Right? Everybody on the same page? We have a small class. I just want to make sure nobody missing, nobody behind, okay? I remember a long time ago, George W. Bush have the program and I got no child left behind, right? Is that right? It's a kind of like a disaster eventually. It didn't turn out to be good. They basically cut everybody behind, you know. They close all those downtown schools, so you are behind. but okay, so I hope our small class here, 19 of you, everybody on the same page. Okay, nobody behind. Okay, so now I want to spend 10 minutes on. Now you're in this class. If you graduate this class, you're a senior engineering student. I think you should be a little bit level higher than the regular high schooler. Okay, so let's prove it. Okay, mathematically. See, everything is from calculus. Okay, modern science is based on the calculus. Okay, from the calculus principle, you should be able to prove this pressure variation with the elevation equation here. Okay, so let's say, hey, we have a stationary fluid. You have a very, very small, tiny, elements. if 1D fluid elements, okay, so it's infinitely small, delta L, right? It's the length. So the area is delta A, right? Infinitely small, okay? 1D element. So I make it a simple shape like this. So the pressure, you have pressure here, one side, okay? How about the pressure on the other side? Right, in calculus, I don't know, but the pressure changes a little bit, right? From one side to the other side. So basically what we want to prove is, you know, for infinitely small two surfaces, the pressure change, delta P, you will have some relationship, okay? We can find out what is delta P, okay? So that's the goal. So, but in the beginning, to prove it, initially we know pressure on one side is P, the other side will be delta P, a little bit change. We want to find out what is the changing rate eventually, okay? So okay, so gravity is going down. So this is the Z direction, so you still have a gravity. Okay, arbitrary angle alpha here, arbitrary, okay? So it tells any angle, it will give you that relationship. If the relationship is independent of this angle, then that relationship, you know, works for any situation, okay? So, but we want to start from the general case with arbitrary angle alpha here. Okay, so this is the W, weight of the object. But by the way, can you give me an expression for the weight of the object? In terms of the thing I give you, delta L, delta A, of course, density, let's say density is rho, or use gamma, rho G, okay? So what is the expression for the weight? We need the weight later, right? For force balance. Anybody? If I use gamma, think about this. Gamma times what is W?
Times the mass.
No, gamma not times mass. mg is the weight, right? So if I want to use gamma times what?
Times density. I mean, volume.
That times volume, right? Everybody agree? See, m is what? Is rho times v. Is that right? Rho vg. mg. Is that m the density times volume? Everybody? Nobody behind. Everybody agree? Okay. If you don't agree, just remember it. I always like to say this. If you don't agree, it's just accept it and remember it. It's good for you. Save your time. Okay. You can prove it, right? Density is mass per volume. So mass per volume times a volume become mass. Okay. So if you will use gamma, it's gamma times delta V. So what is delta V? Give me an expression for delta V for this element. Anybody? Can you give me an expression? Hey, I want you to guys participate and follow me. Nobody behind. Go with me. You need to know how to calculate the volume of a cylinder. In the quiz, in the test, definitely you need to. So it's a time to review yourself if you're not sure.
The area times the length of it, huh?
So give me the expression. Use the letter I draw on the free body diagram.
Delta A times delta L.
Absolutely right. Okay, that's an expression, right? Okay, so now free body diagram. Well, I'm not done with it, right? So what kind of forces on this element? 1D element. So make it simple. You have a weight, of course. So you have pressure forces. Remember, we'll talk about pressure. Pressure is not a force. But if you want to draw free body diagram, it has to be a pressure force. How to convert pressure into force? Say, let's say you have a force here in this side on this to this surface, what is the expression for that pressure force? P times what?
The surface area.
What is surface area? Use the letter I provide.
A.
Delta A.
Delta A. Okay. So that's one force, right? Free body diagram, right? On this element, you need to get all the forces. You will say, hey, why you have force? This is actually you detach. It's infinitely small, but you still detach this fluid element from other elements, right? This is the fluid element. You know, it's inside the stationary fluid, right? You detach it, actually there's a force to the surface, right? So that's a pressure force, okay? How about this side? So remember how that's a new thing to you maybe, because the direction of the force. I draw an arrow to the surface. Does that make sense? Why don't I draw the arrow away from the surface? It's pressure force. Think about it. Pressure. What do you feel? Think about it. If you are the surface, your face is the surface. If you are the element, okay. I just want to just make you have a real feeling. If you are this element, this is your head. Okay, this side is your face. You're under a pressure. What do you feel? You feel the force go towards your face or leave your face?
Towards.
Yes, always towards your face, right? You feel the pressure. If there's the pressure, you always feel it. You feel it, that means the force is towards you. Does that make sense? Everybody? Yes, hydrostatics is easy to understand, but in flowing fluid, man, if the direction of the flow, then you will confuse. But still, always, if the pressure force is always towards your surface, no matter what kind of flow direction is. Okay, so what is expression for the pressure force on the top surface?
P plus delta P times A, or delta A, excuse me.
Delta A, yes. Okay. I guess that's all the forces in this situation for this infinitely small element. Okay, it's a 1D, so we don't consider on the force on the surface. Okay, to simplify it. Okay, so now what's the next step? Next step after we draw the free body diagram?
Force balance equations.
Force balance equation. But before you do that, you need to ask yourself, you are doing force balance or moment balance? Okay, now you don't have, you know, last time we had the hydraulic jack problem. Actually, we use the moment balance, right? Remember? Moment about O equal to 0. Remember that? Everybody? And try to review everything we learned previously. Don't forget, basically. Is that right? So after the free body diagram, you ask yourself, okay, am I going to write the force balance equal to 0 or moment balance equal to 0? Okay, that's a two choice, two options, two routes to solve problem, right? You have to pick a correct one. Okay, in this problem, there's no rotation considered here. Okay, so we should try force balance first. Okay, so if the hydraulic jack problem, remember the lever? You have to rotate it, right? Then obviously we're going to go through the moment balance route. Okay, so here is obviously we want to try force balance first. Okay, summation of force along which direction? Let's say along this element direction, L direction. If we put on the slope, you want to put the force balance along the slope direction, right? Remember that the board sliding down the ramp. Remember that example? We look at the force balance along the slope, right? Okay, same thing here. You want to force balance along the element direction, orientation of the element, right? L. So that should be equal to 0, hydrostatics. Okay, write down this equation to earn some points in the quiz or tests. Okay. Right, everybody follow me? So far, so good? Nobody behind? Good?
Yes, sir.
Okay. Now, expand this equation for me. Summation of force along L direction equal to 0. Can you write down expression to expand this equation? Okay, of course, equal to 0, everybody can write. Okay, your job as an engineer basically is step-by-step, follow rules, follow procedures. Okay, it's not just solving problem. In the real life engineer, I deal with a lot of people, a good engineer just follow the step, follow the procedures. Okay, do his part within the process. Okay, so now the process is now you have a general equation here. You know the direction. Okay, can you expand this equation into many different terms here? How many terms in the left-hand side of this equation? Summation force along L direction.
3.
Okay, 3. Which 3?
The one going towards the surface from the bottom, the one coming towards the surface from the top, and then the weight.
And the weight. Okay, you talk about weight. Do we need to separate into 2 components?
Yes.
Right. So this is W. This is angle alpha. Okay. So this component will be considered. Normal direction doesn't matter. Okay, we're doing the L direction. So write it down. P times delta A. Okay. Minus, notice, be careful the sign, okay? You have opposite direction of in the top surface. P plus delta P. Now it's easy, right? Times delta A. Then minus this force, also minus is W. We have a W. Gamma delta A delta L times sine or cosine? Trigonometry. In this class, you really need to be good on the trigonometry. Sine or cosine?
Cosine.
Everybody agree? Sine? Well, I have 2 answers. Which one's right? You are looking at this component, right? This is the W. So you're looking at the one in front of the angle. So should be sine or cosine? Well, it's another guessing game. You need 100% know this, Anybody? I need the third one. I have heard one say sine, one say cosine. Now, do I have a verdict?
Since it's the opposite, angle, so it should be sine. It's the opposite side.
Oh, I have a third one, sine. Okay, do I have a?
I agree, sine.
Yeah, I think more people agree with sine, right? It is a sine, right? This is this line you're talking about. So in the right triangle, okay. So W is the longest side, right? So it should be, it's in front of the angle, so it's sine. Okay. So okay, we expanded this equation. Now we can simplify it. Now it's too long, right? A lot of things has the same stuff, so we can cancel. Anything we can cancel first? Okay, first of all, I think every term has a delta A, is that right? Can I cancel delta A? Yeah, I can. Is that right? Everybody? Right hand side is 0. No, don't worry. No need to worry. So also we can cancel this P. See, P minus P plus delta P. Okay, that's a great thing. We canceled, eliminate this actually general pressure value. It doesn't matter. Only delta P matters. Okay, so it becomes negative delta P minus gamma times delta L sine alpha equals 0. Okay, everybody on the same page? Do I need to explain anything on here? These are the pure, yes.
Can you explain how you was able to cancel out delta A and it was 3 times? Like you have delta A 3 times. Like, can you explain it? How you was able to cancel all three of them?
Divide by delta A.
Oh, I see. Appreciate that.
You're welcome. Okay. See, I like to use equation to tell. Okay. Okay, let me erase this. Okay. Now, this is the form, okay, we got from, okay? So we can do some further elimination, okay? Here, let's say, if I rearrange it, okay, I put the sign and a gamma and the sign to the right-hand side. If I rearrange it, divided by delta L, both sides, okay? If we divide by delta L on every terms here, it will be delta P over delta L equals to negative gamma sine alpha. I just want to make it look like this because eventually I'm going to turn into derivatives. So delta over delta. Okay. Is that right? Check it. I divide by delta L every term. So delta P divided by delta L. This term is gone. 0 divided by delta L is just 0. Okay. I move this to the right-hand side. I change the sign. Okay. That's a much better form. Okay, I like it, but it's not the end of the story yet. Okay, I have a sine alpha here, and I have a delta L here. These are the arbitrary numbers. You cannot get a final relation with arbitrary information in there, right? You have to have certain information like P equal to gamma H. Okay, so only if you change it with H. You don't want to say, hey, there's a finite element angle and this kind of thing in there. So let's get rid of sine alpha, okay? How do we get rid of sine alpha? Okay. Did I hear anybody talk about it? You have any questions? It's good? Okay. Sine alpha, I need to draw this triangle. So sine alpha, this angle is alpha, okay? So sine alpha, in terms of this, hey, this is the z direction, vertical is z, right? So the height of this triangle is delta z. Is that right? Right. So what is this longer side in this triangle?
It's L.
Delta L.
Delta L, yes.
Use the letter I write on the free body diagram. You do the same thing, okay? Be consistent. Stick with your free body diagram. Can make your life a little bit easier on the process. Okay, so sine alpha is what? Actually equals delta z over delta L. Please turn down your mic if you're not talking.
So that's what I was talking about because she told me that I was the
Hello? Anybody's talking? Okay. Everybody follow me? Sine alpha is delta z over delta L. Okay, that's good. We'll get rid of sine alpha. I hate sine alpha because alpha is an arbitrary angle. In different problems, you cannot have an arbitrary angle there. Okay, so okay, that's even better. Look at this equation right now. You have delta L in the denominator in the both side of the equation. Delta P over delta L now equals negative gamma delta Z over delta L. So can we cancel the delta L?
Yes, sir.
Yeah. Let's move delta Z to the left-hand side. Now, instead of delta L in the denominator, we have delta Z in the denominator. So delta P over delta Z equals negative gamma. Wow, that's beautiful. Right-hand side is a constant, gamma, rho G. Okay? And then the left-hand side, hey, delta P over delta Z, what does that mean in calculus? If you see this, can I move to the next page to repeat this? Write down this, delta P over delta Z equals negative gamma. What do you do if you see this? You know, like every time you see this, you always want to do is take a limit when delta Z, if delta Z is infinitely small, close to 0, right? That's exactly our case. Our delta Z is infinitely small because we're talking about infinitely small element.
Yes.
Okay, what does that equal? Take a limit when delta Z intend to be 0. Does that become dP over dZ equals to negative gamma? Okay, so this is your solution here. I said it's a solution, but it's not. It's a differential equation, right? It's the simplest differential equation you can have. It's a derivative equal to gamma. You can solve it, right? Do you? Okay, so now when you solve it, you will have practical, you know, I took all my calculus in undergraduate, everything. I really don't know what's the reason. You know, the teacher didn't do a good job convey the idea why we need a calculus. Okay, when we solve calculus is really for a particular purpose, okay, engineering purpose or scientific purpose. Okay, when you solve this, it must be a actual application applied to this equation. Okay, so this equation basically applied to the pressure in a hydrostatic fluid. So let's say you have a tank. Okay, Z dimension here. Okay, you have elevation from here, 0. This is the origin in the bottom. And the top, when Z equal to H, let's say. Okay, so for the tank, what is the pressure inside of this tank? Okay, so for this application, you need this equation. This is the solution we derived on the previous page, right? Okay, that's for this problem, okay? So now can we solve it? Yeah, we can solve it. That's easy, right, everybody? Okay, you can, well, there are different ways to solve this. You just take integration, right? If I were you, what I learned is, you know, I move the dz to the right-hand side. Okay, is that right? To the right-hand side, then I take integration. Is that what you taught? Right? So from Z, from 0 to H, that's the range for Z, right? The P, the range is, you know, the P in the bottom, let's say a capital P. What is the pressure on the top?
Delta P or P plus delta P?
No, in this reality now, forget about the finite element.
Atmosphere or 0?
Atmosphere, yeah, 0, right? We use gauge system. So is that what we do? This is the procedure for doing the integration, okay? You have a dP and a dz, then you have the range. Okay, be careful, consistent from where to where. You're from the bottom to the top, 0 to H, then your pressure is from the pressure, high pressure to the bottom 0. Okay? Be careful. In this class, is the only mathematics, calculus, no hope otherwise. Everything you cannot see, right? Okay, you have to solve it, okay? Everybody, did you agree? I don't want to go with somebody behind, okay? Is that good so far? I haven't solved it yet, but to reach to this step, do everybody can do? Do everybody be able to do this? Okay, good. Yeah, give me some response. I really like the in-class, you know, teaching. Then, yeah, people give me all kinds of response, you know, I can tell, you know. Okay, good. So then we just solve it, right? So how do you take integration of dP? Basically, it's 1 dP, right? That's why I say it's the simplest differential equation, right? So what is integration of 1 dP? just speed. Right? Right-hand side. Oh, by the way, do you use this sign as a range? I put a long line here. Okay, you understand, right? Okay. So this is the capital P. That's a value at the bottom, which is our unknown here. Okay. So right-hand side, gamma is a constant. What do you do with the constant? Move the constant out of the integration. It's become 1 dz. So same thing, right? Okay. So what's the next step? So you can substitute these values into P and Z. Okay. 0 minus capital P equals negative gamma times H minus 0. Okay. So negative P equals to negative gamma H. So P equals gamma H. Bingo. We proved it. Okay. That's a major point today in this class. You are one level higher than a high schooler. Okay. You use the fundamental of calculus to prove this physical principle. You see, everything, all the calculus serve the purpose, either chemistry or physics, mostly physics in the old time. Okay. So I guess that's how we do it. Okay. I have 2 minutes here. If you don't do the definite integration, what about the indefinite integration? What do you get? Let me write down the solution. What do you get? You will have P equals to negative gamma Z plus what?
C.
Any arbitrary constant C. Okay, so we are gonna utilize this expression a lot later, okay, from next class, okay?
I have a question about this.
Yeah, go ahead.
On your finite integration, why did you go from P to 0?
P has a range, do you agree?
Yes, sir.
Okay, basically these are the two limits. So Z, you look at the range of Z. Do you understand from 0 to H?
Yes, sir.
Okay, because on any location here, there's a Z, right? So the range of Z is from 0 to H. Okay, so when Z is 0, what is the P?
The pressure at 0.
That's right, it's a capital P. I don't know the value. I put a letter here, I don't know. When
Okay.
Z equal to 0, you have a pressure down there. Okay, I put a letter here. When Z equals to H, what is the P?
Would it be atmospheric or just the pressure at the top?
Atmospheric pressure, we use gauge, remember? Okay, seems like you're hesitated to say 0. Okay, atmospheric pressure in the gauge system is 0. Please confidently say it, okay?
Yes, sir.
Okay, so these are the two limits for the two variable P and Z. They have to be consistent. Okay, did I answer your question?
Yes, sir.
Okay, good. Okay, now let's do the quiz. Okay, quiz will be on a surface tension problem. Okay, if you did the homework, you will be benefit. Although it's not the homework problem, but it's really similar. Okay, okay. Let me draw a. Okay, you have a cylinder sitting on the water. Okay. So you are trying to pull the cylinder up. Okay. I want you to calculate what's the force required to pull the cylinder up. This cylinder has a length of 10 centimeter and the diameter 1 centimeter. Okay. By the way, turn on all the videos if you can. Okay, right now it's because it's a quiz time. Okay. So what I want to draw one more thing is if you have a front view, what happens is this. Okay, Michael is coming. And actually you pull the water up, right? This is the water down here. This is your element, right? The cylinder surface. So basically you try to pull it up like this, but the water apply the, you know, it's surface tension, right? Okay, apply the surface tension force on it to stop you from pulling this cylinder out of the water. Okay, so then water surface tension is 0.073 Newton per meter. Okay. What's the force required to pull it up? Okay, so let me guide you. What I really want, okay, in the grading, okay, the first thing I want is a clear free body diagram. A clear free body diagram with the drawing, with all the arrows for the forces, okay, and all those ladders representing each force. Okay, that's one thing. The second, I wanted the equation, main equation, for equation, either force balance or moment balance. Okay, the third thing, I want a length, the water line. I want you to separate, calculate the water line. Okay, that will be point associated with it. The main equation, then to expand to the expansion, right? Okay, then calculate the water line for me. The 4 is the whole entire calculation procedure. Phi is the final answer of F. If you just give me a final answer of F, you get 1 out of 10. Okay, let me make it really clear here. I want every step of this five steps here. Okay, exactly. I want to give you, train you to have the habit of solving engineering problems following the correct procedure. Okay, so
what was part 4 again?
The final answer of part 4, entire calculation procedures. Okay.
What 3?
3 is the length, the water line, the interface. I give you a hint already here, right? I write this down is for you to be able to solve it. Okay, that's also at least 2 points on the length. Okay, but it's a super easy problem actually. But I want to see. I don't want to just see the answer. I want to see all the, even it's a super easy problem. I want to see all the steps you provide. Okay. Yeah. What's your question?
Is that 0.073 or 0.00?
0.073. That's water. You can remember it also. Memorize it. It's water surface tension. You probably need to. Okay. 0.073 Newton meter. Okay, go ahead. You have from now to the end of the class, 10:45. Okay, I'm opening the summation site in Moodle. Okay, so make sure you finish it 2-3 minutes before the 10:45 and prepare to submit to Moodle. I want everybody to submit to Moodle.